Hello everyone. Previously we had discussed on the counting sort algorithm, right? So today we'll be discussing the Radix sort algorithm, right? So let's get into the definition part. So what it says here, Radix sort is a non-comparative integer sorting algorithm. Just keep this in mind. Radix sort is a non-comparative integer sorting algorithm that sorts the data with the integer keys by grouping keys by individual digits, right? It uses a stable subsorting algorithm like counting sort for each digit place, right? So this is about the Radix sort. Again, it is a non-comparison integer sorting algorithm that sorts data with the integer keys, right? So by grouping the keys by individual digits, this is important. It uses a this one stable subsorting algorithm like counting sort for each digit place, right? Simple. So let's get into the this one explanation part. So just keep this in mind. Radix sort works digit by digit, right? Single digit by digit, right? So starting from the least significant digit, also known as LSD, to the most significant digit, also known as MSD. For each digit position, it uses a stable sort like counting sort to order elements according to that digit, right? So this is fine. What is that? For each digit position, it uses a stable sort to order elements according to that digit, right? So this is fine. After processing all the digits, the array becomes completely sorted, right? After processing all the digits one by one, the array becomes completely sorted. So these are the steps, 3 steps, right? First, it works digit by digit, starting from the least significant digit to the most significant digit, MSD, LSD to the MSD, right? So this is fine. For each digit position, it uses stable sort, like whether it may be simple example like counting sort to order elements according to that particular digit, right? So after processing all the elements, the array becomes completely sorted, right? So the time complexity, just remember this one, try to remember this one, big of d into n plus k, right? So d is nothing but, see here I have mentioned this one, number of digits in the largest number, n is nothing but the number of elements, and k is nothing but the range of digits. Usually I will consider 0 to 9 for the decimal numbers, right? So this is fine, man. So let's try to implement the same thing in the form of algorithm or the code, right? So first let's go with the function to do the counting sort based on the specific digit. So I'll just go with function name here, this one, what do we call, just give me a second here, 1 second. Yeah, first we have to apply the counting sort, right, within the Radix sort. So I'll just go with counting sort. Let me pass the parameters array as well as the exponentiation. So this is fine. N equals length of this one. Let me pass array here. This is fine. So the next one would be output equals this one, 0 into n. This is also fine, man. Now count, let me go with count equals 0 into 10, right? So step 1 was this one, step 1, 0 into 10, whatever I have written output. So this part is nothing but, so we are just going with the temporary output array. So this one count, so this is nothing but the count array for the digits 0 to 9, right? So I'll just go with 0 into 10, man. This is fine. Now let's do one thing, let's go with the step 3, nothing but the count occurrences of the each digit. So let me go with for loop for I range. So this is fine. Let me pass n. Let me go with index. So this one is array of I exponentiation, right? So this one, let's go with a modulo 10. This is fine. Finally, let me go with count of index equals count of index plus 1. We have to increment here, right? So by 1. This is fine, man. So this is the step 3. We are done with it successfully. What we did here, we are just counting the occurrences of each digit. Frequency, basically, in simple terms, right? So let's move on with the next step, or the 4th step here. What we need to do, so here we need to convert the count to the cumulative count. So how can we do that? Let's go with the iteration again. Simple. So for I in range, so this one will be from 1 to 10. This is fine. I'll just go with count of I, this one equals count of the previous number, right? So this one will be count of I minus 1. Yeah, this is fine, man. Let's move on with the next step, or the step 5. So we have to build the output array, nothing but we will be going with a stable sort, comma, from n, right? So let's see the thing. So for I in range, so this is fine. N minus 1 minus 1 minus 1, this is also fine, man. So let me go with index equals array of I, so this one by exponentiation, so this is fine, modulo 10, this is fine. Now let me go with output of count, right? So count this one within the array, we are going with the index minus 1 basically, right? So I'll just go with index minus 1. So let's assign this one to the array of I, this is also fine. So let's go with count, this one count of index, so this is also fine, equals count of index minus 1, this is fine. Now let's move on with the step 6, or the final step within the this one counting sort. We have to copy the output back to the array, that's what we need to do, right? So how can we write this one in the form of code? For I in range, so this is fine, n, so this is fine. Now let's go with the array of I, let me assign this one to the output of I, this is fine. Yep, this is fine, man. So let's go with the main this one function, so this one will be radix sort, so this is fine. Let me pass the parameter array over here. So within the radix sort function, what we need to do here, we have to find the maximum number, right? Just to know the number of digits, right? So this one will be max number equals max of let me pass the array, this is fine. The next step would be we have to sort the every digit, so exponentiation, this one will be 1, 10, 100, like that it goes on, right? So this one will be, let me initialize exp to 1, and finally let's write the while loop. So while, so this one will be max underscore num by exponentiation, this one greater than 0. Let me go with counting sort of array, this one is fine, exponentiation. Finally let me go with exponentiation equals exponentiation into 10. Yeah, now we are done with the this one, what do we call, algorithm, right? So now let's go with the example usage method. Let's consider the nums array here. So some random numbers, I'll just go with big random numbers, 170, let me go with 45, so some random numbers, 75, 90, unsorted array basically, right? So this one will be 802, this is also fine, 24, 2, some random number, 66, this is fine, enough I believe, right? So this is fine. Let's make use of the print for the interactive purpose. So this will be original, this is fine. Let me pass the nums here. I'll just go with the radix sort, so let me pass something here, nums, this is fine. I'll just go with print, so this one will be sorted, let me pass the nums array, right? So this is it for the this one, what do we call, algo, along with the example usage, right? So the output that we need to get here is basically what we need to get here is this one, 2, 24, 45, 66, 75, 90, 170 and 802, and ascending order, basically this one in the ascending order, right? So first we are printing the original array, right? So the same array whatever we have considered here as input, so this one itself we are displaying, see here, original along with the nums. After we are performing the radix sort along with the numbers, right? So after performing the radix sort, we have to get the output in the ascending order, basically, as I have said, 2, 24, 45, 66, 75, 90, 170 and this one 802, right? So let's try to run the same here. So I'll just come here, let me give Control J, so this will be Python. Let me come here, right click, rename, Control C, p.py, right? So see here, original we are getting the same, this one the same array, 170, 45, the same thing, ending at 66. Sorted one is this one is in the ascending order, you can just check, 2, 24, 45, 66, 75, 90, 170 and 802, right? So this is fine, I believe, right? So yeah, basically sorted, this prints the final sorted array after all the digits level passes are completed, right? So this is it for the Radix sort. Very simple and this one concise and simple, right? So this is fine, man. Now as we're done with the Radix sort, let me summarize whatever we have learned so far, right? So just try to keep these 2 or 3 points in the mind. So first thing is here, Radix sort sorts the numbers digit by digit using a stable sorting subroutine like counting sort. Just remember this. Radix sort sorts the numbers digit by digit using a stable sorting subroutine like counting sort, right? It is efficient for the numbers with a small number of digits and runs in the linear time for such cases, right? So this is fine. So Radix sort is not comparison based. So this one we know by the definition part, right? So Radix sort is not comparison based, and it works well when the range of numbers is not huge compared to the number of elements, right? So this is it about the Radix sort, right? We are done with the sorting algorithms, right? So next we'll be going with the this one, what do we call, searching algorithms. We'll be starting with the binary search, right? So we'll be starting with the binary search. So we are done with the, these are some of the important this one sorting algorithms, basically 5 sorting algorithms, right? We started with the merge sort, then we went with a quick sort, heap sort, counting sort previously and finally today we are finishing it off with the this one, Radix sort, or the, it is also known as bucket sort, basically, right? So this is fine. Let's finish it off with the topic or with the algo Radix sort, right? So as this one, as I have said, next we'll be continuing with the searching algorithms. For now, this is it. Thanks for watching, guys.